Once again, you're welcome to our training on Advanced Excel. You're welcome to our training on Advanced Excel once again. We are going to continue from where we stopped yesterday. So, we're going to look at logistic distribution. How to run the logistic distribution in Python. Logistic distribution. The logistic distribution is used to describe goods. Now, it's used extensively in machine learning. In logistic regression is used extensively in machine learning, logistic regression, neutral network, and etc. It has three parameters. Now we have the log, we have the scale, and the size. In other words, it has three arguments. Why using the logistic distribution function? Now the log is the main, where the peak is by default is 0. You can give it a value other than 0. Also, we have the scale. That's the second argument. It takes the scale, the standard deviation. It determines, it tells you the flatness of the distribution. So take note that the log is the peak. It tells us the peak of the distribution. By default is 0. Why the standard deviation? If it's 1 standard deviation, the scale deals with the standard deviation. Why the size of the distribution deals the shape, talks about the shape of the distribution. So now let's see, let's look at an example here. Draw the 2 by 3 samples from a logistic distribution with mean of 1 and a standard deviation of 2. Now, I want to look at the 2 by 3 sample. Now, so we are going to first and foremost, we are going to, from numpy, import random. So we are going to make use of the random function. We've been using the random function. So we are going to pick the random function to get a random distribution number. So that will give us a random number. So we're going to use the random function and the random method. That's what we're going to use. So we call x equals to the random method dot logistic. Then we're going to pass these three arguments. The first argument we're going to pass is the log. And we already said the log talks about the peakness of the distribution. Then we talked about the scale. The scale deals with the standard deviation. Remember, we want to do a logistic distribution with a mean of 1, that is a log of 1, and a standard deviation of 2. And this is just the size of the distribution. Now that gives us the size of the distribution, whether it's bell-shaped or is elliptic or mesogotic. That is, the distribution is become larger and larger at the bottom. So we are looking at the 2 by 3 array. So that's where we put the size, the 2 by 3 array. So data set. So we are going to have 2 rows and 3 column data sets. So that's the number of data sets we want to use. So we're going to use this random.logistic to get random number of 2 rows and 3 columns. Now we're going to get 2 rows. It could be 2 because this random number is going to bring 2 rows and 3 columns, just a random number. 2 rows and 3 columns. That's row. Then we come here. That's another row. Then and 3 columns. So that's what we're trying to see. We're going to bring 2 rows and 3 columns. It's going to draw a sample of distribution from that. So let's go to now. This is my Jupyter notebook. So we're going to write this code from numpy import random. Okay, from numpy we're going to report the random method x equals to the random dot the logistic. Random dot logistic, we have the log of one. We have the scale of two and the size. Okay, size is 2 by 3. Okay, we're going to tell, okay, print X. Okay, we're going to tell this to print X, and it's going to print X, and we'll run this line of code. Now you can see it's giving us a 2 by 3 logistic distribution. Now it's giving us 2 by 3 logistic distribution. You can see it's giving us 2 by 3 array. Now you have 2 by 3 array. So, and this gives us a mean of 1, and then the size of the distribution, that's the scale of the distribution. So, now let's look at the another logistic distribution example. Now, visualization of logistic distribution. Now, with this, actually want to plot the distribution. Now, in order to plot the distribution form, we're going to first and foremost import NumPy. Remember, we stopped at NumPy, how to use NumPy in Python. Remember, NumPy is one of the packages in Python. So we look at NumPy in Python. So first and foremost, we have to import NumPy. So from NumPy, we are going to import the random. So from NumPy import random, so we want to use the random function. Then we are going to also import the matplotlib. But now we're not talking about the matplotlib package. But the matplotlib package helps us to plot charts in Python, helps us to plot various charts, visualization, graph. Whenever I want to plot chart graph, you all make use of the matplot, because matplot has a lot of functions that helps to draw, plot different types of charts in Python. So we're going to look at the matplotlib. We're going to play .pyplot. So this is what we're going to use. The matplot is a package, but this is a method we are going to do pyplot as ply. So, and we have import Seaborn as scene. So now if we are not going to use as ply, that means we are going to use we have to use others. So it's either you use it as ply or you this is just to abbreviate it instead of using the O of this. That will be too lengthy. So now we import the Seaborn. So what we're going to use now is this. We've already imported the Seaborn. So we're going to do the Seaborn dot displot. First and foremost, we're going to do this is random.logistic. Now we already know how to work with this. Now this random.logistic helps to bring a random number. This helps to generate random values. So the random.logistic and the random values are logistic distribution. So that's why we say random.logistic or random.normal. When you're dealing with random.normal, you're dealing with something of normal distribution. So we're talking about random.logistic. So the random value that's going to generate will form a logistic distribution. So we say random.logistic. What is the size? Now, recall we are talking about the size of the logistic size equals to 1,000. So we need the 1,000 for the size number of array. So we need to generate up to 1,000 numbers. So random.logistics. So this will give us the n should be 1,000. That's what we're trying to say here. Then this is an argument we can pass through the kind argument k. So we use the py.plot. Now this is a matplot, just as I said. Now we use a matplot package in Python, matplotlib package in Python to plot various type of charts. So in this particular case, we already abbreviated it to be ply. So ply.show. We already imported it here. So we are going to use the ply.show. So once it generates this number, I'm going to move on to this. I'm going to run this particular line of code. So from NumPy import random. So from NumPy we import random. So import math plot lib. Import matplotlib dot py. Import matplotlib dot the py plot. We import matplotlib dot py plot as right. Okay. Then we are now going to import. I'm going to import the Seaborn. Seaborn also is another package in R. Is another package in R. So import Seaborn as this. So now we're going to run this code. The Seaborn dot going to use the dixplot package. But before that, remember we have the random dot logistic. Okay. I equals to the bracket close.